Hey everyone, welcome to the Generative Edge, the podcast that keeps you up to date with the latest news and events in the world of generative AI. I'm Stephanie, and I am a consultant at Deloitte Central Europe.
Hi, I'm Brandon. I'm the Natural Language Processing and Generative AI Specialist Lead for Deloitte Central Europe.
Today we're going to talk about how to choose the best large language model, or LLM, for whatever task it is that you're trying to complete. So right now, there are so many different large language models available, so many different generative AI solutions. And our goal today is to give you at least some sense of direction as to how to make the best decision for your use case or for your business. So, Brandon, you are our expert here. Let me just ask a really vague, open question.
Okay, I love those.
What are we supposed to be thinking about when we're trying to choose a large language model for whatever particular task it is that we're trying to achieve?
Several things. Let's start with energy consumption, right? Okay, so I know that I hit this topic quite a lot, but it's the reason that I hit it quite a lot is because it's so important. Yeah. Because not only does energy usage impact the environment, it's also the largest cost. So if you have to pay for the energy that you use, these models are extremely large. They use a lot of computational power in order to run, and so that's your number one concern. In order to figure out what a good model looks like for your use case, depending on the size, you need to take into account, okay, is this solution going to be scalable? Do I need to scale it to 10 people, 100, 1,000? Do I have 1 million subscribers who are going to be using this per day? And then how often are they going to be using it? Are they going to be using it on the weekends and during the nighttime or all throughout the day? Does it need to run on their personal laptops? Is it software that's going to run in the cloud and be organized from there? Can it scale up and down? All those questions are pretty typical questions that you would ask yourself for like any AI or any cloud-based software solution. But it's particularly important for generative models because the way that services are set up now, you pay based on your usage, not necessarily on the amount of energy going in or out of the system, but like how many images and how much text you actually put through.
Sure.
And that correlates with the energy usage that's subsidized by the service provider. So that's the first thing. It's the energy usage. The second one is latency. So
what does that mean to the average?
Sure. For non-technical people, it's really important for some solutions that the answers or something that you get from a search need to be instant, or they need to look like they're instant, right? So if I was on Google and I did a search and it took 1 extra second, I might be less likely to use it later if I just see a blank screen, or if the models that are being used to run a chatbot or something can only type text half as fast as I can read them, then that leads to a negative user experience. And so latency is another thing to consider. How fast am I calculating the outputs that I need to drive this solution? The third thing, I guess, would be accuracy, of course. So you need to, and data quality.
Okay. Yeah.
I think sometimes we skip over this, which is not good. But for my use case, does the model that I'm choosing actually work well for that use case, or does it give really terrible outputs? Do you even know? Is it a question that you've asked or tested? Does it need to be tested on generically available benchmarking data, or do I need to put it on a specific use case with data that my team put together? So those are the three major things I would consider when trying to figure out what model to use. Apart from, of course, the use case, because not all language models do the same thing. I guess the use case, like what you're trying to do, that's another thing to consider, of course.
But I think that's something. So what you just laid out for us, those 3 points.
Yeah.
I mean, obviously in the business world, cost and efficiency and all these things are obviously extremely important, and most of the time something that will decide whether a project does go or not, right? But I think in terms of generative AI, it's not always clear that there are so many options. So on the one hand, we're being bombarded with all these new things, new solutions coming out, new toys to play with. But at the same time, there are very big names in the space. So, I could assume that someone who's not super familiar with generative AI and large language models would be like, what about that chat GPT stuff, right? Can you do something with that? So Can you maybe break down a little bit what some of the modalities are? What are the options even that we have for generative AI solutions? Because I'm sure that calculates into that factor of choosing the best model for what you need to do.
Yeah. So this is what we refer to when we say the model zoo. It's basically just every possible type of language model out there. Let's maybe start with the big names, which are going to be like GCP and AWS and Microsoft Azure, who is a service provider that allows enterprises to use like OpenAI's models on their infrastructure. So generally what happens is like a service provider or somebody that's coming up with these large language models, they will make available different sizes of those models and also two different types usually. So there are lots of different types of generative models. They can generate text, video, code, images, whatever else. I'm primarily working with text, so at the moment, let's primarily talk about text generating models, like GPT, for instance, GPT-3, GPT-4, GPT Turbo, GPT-2. There was a GPT-1 actually, nobody talks about. Or like for GCP, this would be like Bison or Unicorn, or I can't remember the names of all of the models. To be honest, it literally is a zoo.
I mean, it sounds like a zoo based on the names even.
Yeah, for sure. And it's impossible to keep track of all of the different models. At one point, you could maybe have all the major ones memorized, but I mean, it's so many. So yeah, these providers will generally have different size models, and they do different things usually. One of the most important modalities would be embeddings. So these are like vector embeddings. This means, computers can't actually read text. They don't understand human language. They compute based on ones and zeros. So you actually have to represent words, which are this unstructured, non-computational form of information, into ones and zeros. So you put in text. These models learn how to encode the text as a long string of numbers. So like the word for cat might be represented by 1,000 different numbers, like 1,110, 0.15, etc. So that's how machines are able to understand language, right? So you have these embedding models that that's their only job. They take in text and they give you a vector representation of that text. And by doing that, you can actually do mathematical operations with language. So if you subtract the value for male from king and then you add female, then you get something close to the vector representation of queen. Stuff like that. It's like really cool computational linguistic stuff.
Sounds cool.
It's very cool. And it's also been around since like the 70s. So it's not a new concept, but the models that we have now are so much more better at doing it that it's really worth building out the business use cases with it. The other modality is just text to text. So I type in a text. I'm like, can you summarize this article? Here's the article. And then I paste it. And then out comes a summary. And that's probably what makes up the bulk of the like enterprise use cases. And for different use cases, you don't really need the largest model. So GPT-4 at the moment is like top of the leaderboard. GPT-4 Omni, which is the one that takes in image and text. But not all of them need to be that large. So I might need to do something like extracting what we call named entities from text. So I need to get all the people, the places, the companies that are mentioned in a text, and then put them in some kind of structured database. This is like a really typical use case, NLP use case. And you can do it with a very, very small model with, less than 1 million parameters, which is really, really small compared to GPT that has hundreds of billions of parameters. So it's way more computationally efficient. It's way less latent. So there's like, you don't have to wait for it. It happens in milliseconds, right? So it makes a really good use case. You can do the same thing with the generative model, but you're going to pay 1,000 times more money in energy usage. It's going to be 1,000 times slower. So you need to account for those kinds of things when you're choosing those models. And then there's the middle road, which are these like BERT models that have been around since, I guess, 2018 or so. So we used to call these large language models because they had hundreds of millions of parameters, which of course now that is really tiny compared to like GPT, but they're still perfectly good for some use cases, for summarization, for information extraction, for extractive question answering, and these like typical NLP stuff. Small, computationally efficient, plenty of use out of them still to come. It's only really when you have something that really requires generative AI, like coming up with 3D models or like painting pictures and stuff, where you would actually need to use a generative model. And then depending on the complexity of that use case, you choose the size of the model.
Yeah. It almost, to be honest, it sounds a bit like choosing a car, like the appropriate car for your needs and purposes. Like, okay, I live in a city, so of course I'm going to need a smaller car that's more energy efficient and can fit into really tiny parking spaces versus someone who like works out in the countryside on a farm might need like a pickup truck or an SUV or something like that, and it needs a bit more power behind it. So to me, that's a fair comparison. But would you agree with that?
Yeah, I totally agree. Actually, the image that comes to mind is like Taylor Swift taking an airplane across like to the grocery store. That's kind of like, what it feels
we're
like.
We're all Swifties here. Don't worry.
That's kind of what it's like to use like GPT-4 to like I don't know, get the the title of a news article or something. You know.
We don't need that much power in order to do it. But that I think that helps, especially because, again, there's so many options. You literally called it a model zoo. Because there's so many options there, it really feels like we're a bit spoiled for choice as well. So like, I might want to get like, I don't know, the fancy Porsche of all the generative AI models, but it actually is not going to do what I need it to do for my use case or whatever purpose it's being utilized for. So where, you said it's a zoo, where do we go to try and figure out what animals are in the zoo or what cars we want to purchase in this case?
Being in the business for 5 years, I'm really familiar with Hugging Face. Hugging Face is like the repository for language models. It's been there for several years, and that's where I always go first. They don't just have these models available, which range anywhere from like the tiny ones I was talking about to the BERT models to GPT-sized models, even publicly trained ones that are publicly available. You can download them and launch them on your computer, right? Or in your data center if you have like 85 terawatts of power or something.
My spare data center I have at home, yes.
But they have a leaderboard for like LMSys, I think is one of them. The chatboard arena that tells you how which models are top performing according to what people prefer to use. There's also leaderboards for benchmarking. So all the large language models that are commercially available out now go through this litany of tests. You benchmark their performance on each one of those tests so that you know how good they are at particular use cases. So definitely look at that. And in addition to that, I think the best one for enterprises is I think it's called like just the LLM leaderboard, period. These are the commercially available ones through service providers like OpenAI and Microsoft and AWS. And they don't just list the performance on the benchmark, but they also list the latency, the throughput, so how many tokens per minute it can type, basically. So you know that, is this one going to be faster than a person can read, in which case it's good for things that need to be like on live systems? Or is it really slow and very accurate so I can put it into a solution that doesn't necessarily need to be customer facing or has some kind of asynchronous process, like taking in news articles, extracting useful information from them and putting it into a database. You don't need to do that live, so you don't actually care how fast it is. You just care that it's accurate, right? So I would go there. And it also tells you, what is the price per million tokens, so you have some estimate of not just how fast it is, but how much it's going to cost and where you're going to actually call that API.
So it almost seems like a lot of the work of researching all these various models in the model zoo, it's already done for us, and therefore companies don't need to spend a lot of time researching it? Or what would you say is the balance of the research versus like, Hugging Face says I should use this one?
Yeah, it's kind of in the middle. So these benchmarking tests that I mentioned, they're very generic. They're on like high school level math or high school level reading or university level summarization, that kind of stuff. Most of those use cases translate well to the real world, but not all business use cases are generic enough to be considered close to one of those benchmarks. So, for example, one use case that we've built out is extracting financial information from tables in giant PDFs that are like financial due diligence reports. It turns out it's really, really difficult to do, and there's no benchmarking test for it. So it's something that we had to come up with the testing framework. We had to come up with the evaluation data set, and then then the software behind it to actually run the pipeline. And then once we got all that together, then we were able to measure the difference between how people perform on that task versus how the model performs on that task. But you don't have to do that for all use cases. I think even for the summarization tool that we built out, we did 200 summarizations that were written by people, and then we compared them to 200 summarizations written by the model, and we had people go through and say, okay, which one do I prefer? Which one is more correct? And only in that case, even though summarization is one of these cases where it's already on the benchmarking database, we can tell how good a model is at summarization if we look at that. It wasn't specific enough for this one use case, even though it very much did look like a benchmarking test. So in some cases you might not need to. In most cases, I would still recommend some level of quality assurance. Otherwise, yeah.
I was going to say, we don't want to let the robots control everything just yet.
Right.
Okay. But that is a fair point. And I think that, as these models, well, first of all, as models become more and more available, because I'm sure we haven't seen the last of the big name models and things like this, for enterprises and companies to really understand where they can get that information, I think it's going to be very useful and valuable to lots of people, especially folks listening, I'm sure. That's the latest from the Generative Edge. If you've liked what you heard, be sure to rate our podcast on Spotify, Apple Music, or wherever you get your podcasts. Thank you for listening to The Generative Edge, a Deloitte Central Europe and AWS production. Your hosts are Brandon Eychaner, Vyasaraj Kulkarni, and Donovan Sprunk. Our show is executive produced by Stephanie Cohen, Vanch Luthra, Ian Masters, and the Deloitte studio in Prague. Head writers are Stephanie Cohen and Brandon Eychaner. Our sound and audio engineer is Wojtek Krasa, who also serves as our editor and videographer. Michal Trusina is our graphic designer. Our marketing and social media managed by Stephanie Cohen and the Deloitte studio in Prague. And our theme song was written and produced by Jakub Flaszek. Don't forget to rate and subscribe on Spotify, Apple Music, YouTube, or wherever you get your podcasts. Thanks for tuning in.